Guys, for the last couple months, we've been watching the Colorado River Basin very closely, looking at the dams, seeing what's going to happen. We understand now that we're in a ridification and we may not ever see that come back again. But we've also noticed other things. One thing about the way we approached studying the water data and everything in the Colorado River was using as close to every data point we could find, whether it's inflow, outflow, height, evaporation rates, and all that. We've been pretty accurate. But now that is a micro problem compared to the macro problem that the entire planet is facing. And so we're going to approach the Arctic in the same way, trying to use as much data as we can. Now, you're looking at what's called the Thwaites Glacier, or some call it the Doomsday Glacier. This thing is the widest glacier on Earth, and the tip of it is setting over open ocean in some places. Now, there's a ridge that comes up to a very short point that it rests on, but all this warmer water that caused that 36-degree rise this year, it was 36 degrees above normal in the Antarctic during the Arctic winter. That warm water is pushing up under this, and there's consequences if this melts. This has happened before. We know of one time in history, it was called the end of the Younger Dryas, which happened to be the same time of the Great Deluge, the Great Flood that the Sumerians talk about, and in the stories of Noah. It just lets you know that how old some of this information is. There was no Great Flood, and there's no proof it was 6,000 years ago, just to be clear. But there was 14,000 years ago, and history shows it because of the floods. Something else about it, and we mentioned it before, is that they knew the ice collapse was coming. And if you go into some of the history, people prepared for it. You know, they built the ark or whatever it was. The different cultures did different things. But what my point is that it happened pretty quick. There was a warning time, but then when the water started rising, they came in pretty quick. A lot of people were caught off guard. And just as we saw, looking at the Bureau of Reclamation's 2027, 2028 projections, we've cut that in about 2 years, looking at the real data. And we may be seeing the same thing with not only the largest glacier in the world, but the entire Antarctic ice sheet. And the numbers are very interesting, not only on how the sea levels will rise with just this Thwaites Glacier here, they call the Doomsday one, but this will destabilize the entire western Antarctic. This is the plug right here, this area that we just saw facing the ocean. But it's a plug, it's an ice dam, and it is starting to move this way. And just this year, the British research team reported multiple large cracks forming throughout it. Why? Because you got 36 degrees above normal temperature, and under the edges, there's great expanses that this warmer water is pushing under this. It's actually lifting some of the tips of the glaciers up and down. Now, this ice flow is, again, this is huge. It's bigger than Texas, has the same amount of acreage basically as Florida. But again, the dam that you were looking at is here. I call it a dam. It's an ice dam. And if this slips off, which the indications that it could, the rest of it that it's holding back will flow with it. When you take this chunk out of this side of the entire ice shelf of the West Antarctic, it says that it will destabilize all the other sections, and they will start to do the same thing. And especially with, you're seeing the record temperatures at both poles. Now, we're going to look at some information and some charts on how the different sea level rises will affect different parts of the nation, things like that. But now this particular section, guys, they are talking about if this thing breaks into pieces and we see it move rather rapidly down, we could see a 2-foot rise in the seas of the ocean. And because of their concern that this breaking down would destabilize and cause the rapid advance of much more of this West Arctic ice sheet. It's broken into about 5 or 6 sections of ice sheets. The East Arctic, and we're talking about the West Arctic. And guys, this is the Trinity Peninsula that we've looked at on the NOAA weather maps, where the warmest water is, and it's washing down. It's washing up under the edges of these glaciers, reaching way up in there with record hot water. Now, we're going to look at the different numbers depending on where the ice is coming from. But this is satellite images, guys, of Greenland's and its melting icebergs. And got that, the numbers on that. Now, it would take all the ice melting into the ocean, but that would cause a 24-foot rise. Now, we're going to look at that model, but that is, again, with a massive break apart and move or melting of the Greenland ice sheets. It's a very large area. So we don't know the scale of it, but during the younger dries, remember the ice sheets were a mile or two high over North America. When they collapsed, we saw massive gullies wash the Grand Canyon. You saw the mesas pour out from the southern Rockies. Tremendous amount of canyon carving and everything because it rushed through, not slowly, but very fast. But again, Greenland is having the same problems. We noted before that the Arctic is having the same heating problems as the Antarctic, even in the winter of Antarctic. It should be the coldest spot on the planet. Now, this is just a depiction, but basically looking at the ice sheet formations here. And notice it says North Atlantic deep water, and the areas coming here, it's called circumpolar deep water, and it eats under the ice sheets. You see this? And that, because now that's warmer water, it's melting from the bottom and the top. But something that's very accurate about this particular illustration, you see where it says the Mendocine Ridge here and how these stack up in very fine points right there. Well, what's not accurately correct here is that, but the bottom of the ice sheet still touch one of these pinnacles in a very, very small place. And you're talking about massive amounts, tonnage and millions of tons, and beyond that, of weight from the ice sheet resting on one of these pinnacles. But there's multiple pinnacles, maybe more than just these two, but that's what they picked up on sonar. But let me show you what they're seeing, guys. Take a look at this. And what's happening, guys, is they're getting so worried that they're having to move the Arctic stations, the experimental stations and all. But the Japanese, they call it a very dangerous drill, but they drilled down through one of the ice caps and dropped sonar imaging down there. This is a side scan image. It looks like a tire tracks in sand, doesn't it? Look at that. But you saw the pinnacle that was sticking up. These are 22-foot gaps. So this would put this probably 60 or 70 foot. That's the main section that has been resting from the pinnacle, from the iceberg that's supporting all of this mass. And as the tides changed, it would rise and fall. But what they noticed is that and it would move backwards towards the mainland. In other words, out here for a while, it would rise and fall. And that pinnacle would dip into, the ice would push down into this area. But they started seeing a rapid advancement back this way. And that's why that pinnacle is important that I showed you in the illustration. It's advancing backwards, and as it's doing it in 22-foot leaps right there. But the point is there's a tremendous amount of pressure. If this is only 6 or 60-so foot of trench from here to here, think again the small point of that massive iceberg the size of Texas or Florida resting in a 60-foot trench. That's not going to last very long with melting water. You're going to see that front of the iceberg start to tilt down because it's pushing the tip down. And the sonar images indicate that glacier, the tip of it, the ice wall, comes down to a very fine point out on the edge of it. And that's what we're seeing here. And that will not hold up long under that pressure. But as it breaks, the tip will dip down, the rear will be pulled up, and it will start to slide out at even faster rates. As it slides out, the warmer much warmer than normal Arctic water will come in and replace it, and it will cause not only a pressure gap that causes the rest of the ice sheets in the West Arctic ice sheet to melt, but the warm water will cause the cracks to expand via heat and melting. Let's take a look at this map, and then we're going to go to the actual data that shows how the oceans will look, especially along the Gulf of Mexico, as we go from a 2-foot rise and up to the other levels that could happen. But notice this particular model started in 2011. Now it's talking about the speed of outflow. If it's red, you got a higher speed moving out. If it's blue, it's a low, almost non-movement. And you can see this is the Thwaites and this is the Pine Island glaciers here. And since 2021, they've noticed a increase in the speed towards the oceans, not only in those, but look at the much larger ones. This one's called the Ice Stream C, Scott Glacier. This may be after Admiral Byrd here. And here, up into the East Antarctic ice shift. These black lines indicate the large, I guess these are the different ice sheets. It's where they've split or whatever. But all the way around it, you're seeing more movement. But again, here is a much larger volume and a much larger ice gate of movement. Notice that. But this is a collection of, what they're saying is these larger areas is a multiple of many flows. And you've seen that in some of the glacier images where it's coming in from the left through a mountain range, coming in from the right, and all coming together like a river, but it's a massive ice flow. But this is, again, the Thwaites is the largest solid piece on the planet, but all of it is moving off land and into the water, causing ocean rises. Now, if you're in the mountains and all along the west coast, it would not be quite as an impact, even at a 2-foot level, as you see in most places, except, again, San Francisco Bay, Seattle and places like that. But this is at basically current levels. Let me pull it up. You can see Louisiana here. We back this out, move it around just a little. Now, before the younger dry ice, guys, you're looking at the edges of what was Florida. Look at this, much wider, 3 or 4 times wider, because the oceans rose 400 feet at that. It's documented. It's even documented that Bermuda was one of the largest volcanoes along the Atlantic section entirely. And now it's just a tip of the Bermuda Island. Very large volcano. But anyway, let's just start right here in New Orleans. Now, this is New Orleans. It's Harvey Tarrytown, guys. You got the bridge going over Slidell and up Lake Pontchartrain, of course. Some of this that you're seeing is because there are parts of this area that are below sea level already. So that's the way the satellites are seeing it. But we're going to start right here at ground zero. And over here, we have a chart. And this is basically zero. Now, we're going to go to the 2-foot level if just the Thwaites Glacier has a rapid meltdown, or even if it's slow, it's going to have the same result. But you see, as I slide this up, we're at 2 feet. Now, New Orleans is not quite an island at this point, but it almost is. Now, you got levees along this area of the Mississippi River. But guys, what happens when you have sea level rises? All the salt water will continue. It's already moved up the Mississippi River, but it will inundate all of the fresh water with salt water. And so you've got this section left. And let's just kind of slide over to our friends. Let's take a look at Houston. At 2 foot, you're going to see some increases. Let me back this back down to zero. And notice the edges, especially your coastal edges. And we'll go back to that 2-foot level. I'm trying to just use the data that's available. You see the inundation, guys? Check this out. Some of the islands are not really exposed that much. But at 2 foot, that's a major problem. Look here. Moving way up into the river system. And it's something you can deal with. Now, you're going to start seeing at that time at 2 foot, back up, not only New Orleans, but you're going to see the Mississippi Gulf Coast get affected. You're going to see widening areas out. This is Diamond Head, guys, going into over Orange Grove, D'Iberville. And look at going up into the Pascagoula Basin here. Then you're going to see a huge surge up into Mobile Bay, back into probably where it has been before. And you're going to see some problems going up into past Pensacola into Ferry Pass, just moving. Now, if we have more problems from the rest of the ice sheet, they're talking about possible 10-foot. We don't have a timeline, but we didn't really have the true timeline when we started the meat investigations. We had to put the data together. Right now, they're seeing rapid cracks, rapid heat rising, and rapid movement along the Antarctic ice sheet. So if we had more problems, if more of that ice came in behind the Theades glacier, guys, we would see many more problems. Now, this is not putting into the equation any of the Greenland ice sheets or anything else. This is just looking at the rise in sea level going from the different feet. And my huskies are in there playing. Now, let's move this elevation up. We're going to go up 8 more feet because they had predicted that's what would happen. And they're saying it will happen when that front blocking glacier releases the pressure on the rest of the ice sheets. So notice New Orleans, we'll stay here, but we'll move back around along the Gulf Coast itself. But let's just slowly move up and watch how things change. See the creep? That's 4 feet. Guys, and at that level, the entire area of southern Louisiana, Chaffelay Basin, all through here now is at 6-foot rise is pretty bad. Now, something you got to realize, even at a 2-foot rise, if we see that, then you've got 2 feet on top of every hurricane. If you saw where the waves came in, some of the big ones, that's going to amplify, plus how far the waves come in because you see the creep. The tides will go up, the waves will. So it impacts in different ways. But now let's go up 2 more feet. Let's go to 8 feet. Look at the expansion. Again, New Orleans is a complete island with a salt river. And guys, Baton Rouge, look, you got the Mississippi River through here, but you are becoming a peninsula out into the new Gulf of America. And moving over to Florida and the Mississippi area, let's see how we're faring here. It's one of the most popular beaches in this area, and this is Pensacola area. This is the Pensacola Naval Air Station, and this is the road that comes out. This is Fort Pickens out here, guys, and look at the water. You see this? There'd be places where you would not be able to drive at 8 feet. So the economy is going to change, and you'll start seeing things like that. In the map, guys, I'll link it, but you can look at the expansion up into the upper bays. Look at coming here. Now, let's look over a little further. Fairhope, Alabama. Look at the difference is now. It's starting to creep up into the rivers itself and go much further in a wider area. Now, let's stay right here for a moment because this is very interesting to me because we got a lot of coastal islands out front like this all the way through Mississippi, too. You got Deer Island, Ship Island, Petty Boy, all of those there, Cat Island. But let's go up and just watch this section of Pensacola as we move up. We'll go up a foot at a time, with this time to 9 feet. Give it time to change. Now, at 10 feet, most of this is underwater. You got a few ridges sticking up along those sand dunes. The rest of it, the highway and everything else, is underwater. It starts to rise back up along Pensacola Beach, but when you come in off from Gulf Breeze, all of this will be underwater too. And of course, you know what that does. It dislodges any type of infrastructure that you have. We don't have a timeline on it yet. We do know that the heat is increasing. We know that the glaciers are moving, they're cracking apart, and you saw that delicate balance of the world's largest glacier, guys, and tapping down on that 60-foot ridge. And you saw the marks. 60 foot of glaciers of supporting the weight of something as large as Texas. Dealing with warm water coming up under at the same time. That will start a very quick collapse. When you break that fine tip off, and there's sonar that show it does come down into that 60-foot tip. then things will change very quickly. Now, New Orleans and New Orleans East through here, through the quarter and all, you still have, even at 10 foot, you're still there, but you are definitely an island. Move over and just look through here, Baton Rouge, it's crept on you a little bit closer. Look, almost to the Mississippi River itself. What's that going to do? That's going to introduce salt water even much higher into the river than it is as it moves towards New Orleans. Let's move over to Texas just a moment. And just as we're seeing in Florida, look at your Outer Banks. You got an island left here coming into the channel near Galveston, guys. Most of the islands are pretty much inundated here, a couple of high spots. And look how far inland it is here and how far it has moved up into, here's Baytown, guys. You know the area. Check it out. We'll just kind of scan the Texas coast. All of these barrier islands will be gone. What does that tell you? Another thing, I mentioned 2 foot rise at every, then you change your tide, you change the height of the hurricanes. But when you've already breached the outer barriers, they are the hurricane walls. Now let's pay attention, and we're going to start the scale back down low and move to 20 foot. Watch what happens into the very southern tip of Florida as we let it go up. You can see the creep into Big Cypress National Preserve. Homestead is underwater. All of that area is underwater. Naples is being inundated. Hollywood, Coral Springs. Let's get up to the 10-foot line. Check it out. Florida, you have a whole new tip. Again, any type of barrier island would be affected, and much of the Keys would be underwater. Look at that. But the globe is changing. We've seen this before. We saw it in ancient history, from the floods of Noah to the floods of the Sumerian text. And I'm not going to get into that here. I'm working on something that will be over in the new Sumerian History channel. I hope tonight. It's been kind of a long day, but it's important information. And I think the time is coming to where we need as much out there as we can get as soon as possible. Times are getting short. Now, quickly, I've got to just move up the East Coast. Looking here. Look at the Outer Banks. You got some sections possibly up and out. And look how far the inundation is. Let's just go back to 0. Let's back it all down. Give you an idea. And I'm going to link this NOAA Sea Level Rise viewer. And here's the Alligator River National Reserve. Here's your Outer Banks. Let's go back up. Outer Banks are going under. The rivers are creeping up much higher, 10 foot higher, as a matter of fact, than what your pier shows if you live on one of these rivers. By the time we get to that point, quite a bit of difference, isn't it? And just looking at the Northeast again, guys, let's check out, when we pull this back to 0, Long Island. And we'll creep it up. You can see the rivers enlarging here. You can see the water creeping in, but you're going to have some of the lowland Outer Bank problems going up to 10 feet. You got pretty good elevation, it looks like. Pull it in some. But you're going to see it eat away at the shorelines and in your shallow areas. Guys, look at New York City. Let's pull this down and take a look at it. One of the heavier populated cities. Look what reemerges is in Jersey. And let's just do that at 2 foot, just to go from 0, because that would be the first thing that we see happen at 2 foot. Of course, some of the shipyards and things, 2 foot is like a good hurricane coming in there. Then you go up and just go up 8 more feet, and you've got a very narrow Manhattan Island. Look in this area. And that's all across the Northeast, too. And this is not a fear video, just looking at the fact that I did not make up and throw the alarm that the British Solar Research Team did when they announced we had a 36 degree above normal temperature in the Arctic winter. And that's why I'm doing this video. It's something that, one of the reasons is many of us live above this elevation. But there's people that are planning on moving or staying where they are. And we're already seeing the sea rise increase. Over the last few years, we've noticed that the Earth's getting warmer, and the rate of sea ice melt is increasing for sure. But I wanted to point that out again. We're going to talk about the Antarctic a little bit different. We're going to mention a few other things in the Sumerian text that are very interesting. So watch for, I'm not sure what time yet. I'll put it and leave 30, 45 minutes, an hour a time for everybody together as we do the premieres. But I'm not sure the time yet, so don't hold me to it. It's been a long day. But guys, we love you. Our Father loves you, and this is a major heads up. You be safe.